Welcome to this video on React Native internals. After watching this video, you'll be able to identify the core components of React Native architecture, describe how the shadow tree works with the Yoga layout engine for UI rendering, explain the role of different threads in React Native architecture, describe how the JavaScript bridge facilitates communication between JavaScript and native code. Imagine you want to build a mobile application that should run smoothly across various devices. By exploring React Native internals, you'll uncover how React Native manages communication between JavaScript and native code, helping you optimize performance and resolve issues effectively. This insight into React Native is key to creating a high-performing, responsive application that delivers a consistent user experience. React Native internals is a powerful architecture for creating mobile applications by integrating JavaScript and React on Android and iOS seamlessly. The architecture has two critical components, native module and the shadow tree with the Yoga layout engine. Understanding these components is essential to understanding React Native architecture. Let's first understand the native module component in detail. A native module is a code written in a language native to the platform, for example, Java or Kotlin for Android, and Objective-C or Swift for iOS. These modules bridge the JavaScript code in your React Native app and the native capabilities of the device. Your JavaScript code does not need to manage platform-specific complexities. It calls the built-in functions provided by the native module. This bridging process allows your app to utilize powerful native features while still being primarily developed in JavaScript, ensuring that your app can perform tasks that would not be possible with JavaScript alone. Using a native module in your React Native app is essential in several scenarios, particularly when interacting with device hardware. For instance, if your app needs to access the device's features such as camera, microphone, GPS, or sensors, you rely on a native module. These features are specific to the mobile platform and cannot be fully controlled by JavaScript alone. Consider an example where you want your app to allow users to scan barcodes using the device's camera. Barcode scanning involves accessing the camera, capturing the image data, and decoding the barcode, which requires platform-specific handling. For this, native module code written in Java for Android and Swift for iOS is already available to manage camera access, process the image data, and decode the barcode. On the JavaScript side of the code, you would need to call a function like scanBarcode, which will invoke the native module to start the camera and scan the barcode. Let's now learn about the next component, shadow tree and Yoga layout engine. React Native uses the Yoga layout engine to decide the arrangement of components. Layout involves creating a shadow tree, a simple version of the UI structure designed to control layout calculations efficiently. Let's learn in detail about the working of shadow tree and Yoga layout engine. The first step is shadow tree creation. As you define your code, React Native automatically generates a corresponding shadow tree. In this light tree, each circle represents a node corresponding to a component such as text tag or any other tag, creating a similar shadow of the tree. This shadow tree displays the simplified version of your app's structure. The next step is Yoga layout calculation. Yoga computes the position of each node in the shadow tree by considering the styles you have specified at the component level, such as flex, padding, and margin. This computation ensures all components are arranged and operate efficiently, even when UI changes occur. The last step is the layout application. React Native uses the layout calculations from Yoga and applies them to the native views. The native views are then rendered on the screen to get the intended final output of the user. Next, let's learn about React Native's thread architecture, which is key to your application's efficient performance. The first thread is the main native thread. This thread manages tasks involving native modules, which are pieces of code written in languages like Java, Swift, or Objective-C. These modules access platform-specific features, like the camera or GPS. Having a dedicated thread for these operations ensures that native operations run alongside the JavaScript code without slowing down the rest of the app. This makes the application run faster and more efficiently. Next is the JavaScript thread. This thread manages your app's logic, runs the React and JavaScript codes, controls the app state and manages decision-making about what to display. If this thread gets overloaded with multiple tasks or heavy calculations, the app might slow down and become less responsive. So it is important to keep this thread running smoothly so that the UI can update quickly. The last thread is the shadow thread, which manages the layout calculations for your app's UI. This thread uses the Yoga Layout Engine to decide the positioning of different components on the screen. Layout calculations can be complex. So by having these layout calculations on a separate thread, the JavaScript thread is free to focus on other tasks, ensuring the app runs smoothly and efficiently. It is essential that all these threads run smoothly so your app can run smoothly. Next, let's understand the JavaScript bridge, a crucial part of an app that provides seamless native communication. It allows JavaScript code to interact with a device's native features, like the camera. The process by which the JavaScript bridge facilitates communication between JavaScript and native code involves 4 steps. These steps are JavaScript execution, bridge communication, native module invocation, and response sent back to JavaScript. Let's look at each of these steps in detail. During the first step, when you interact with an app, the JavaScript code runs and decides what action should happen next. For example, the JavaScript code might decide to open the device's camera. If the action involves device's native features like accessing the camera, JavaScript sends a message to the native side of the app through the bridge. This message is in a format that the native part of the app can understand. Once the native side of the app receives the message, it reads the message and triggers the correct feature, such as turning on the camera. If the native feature needs to send something back, like a photo from the camera, it sends this back through the bridge to the JavaScript code, which then processes it. This seamless communication between JavaScript and native code makes complex app interactions possible. Now, let's understand the process of JavaScript bridge communication using an example of clicking the photo through a camera. This diagram illustrates the process of the JavaScript bridge, which connects JavaScript code to native components in a device application of camera. The process begins with user interaction and JavaScript execution. Here, the user starts an interaction with an app like tapping a button. This tapping of button triggers the JavaScript code to run and decide the next action. The next step is bridge communication. In this example, as the action requires a native feature related to opening the camera, JavaScript sends a message through the bridge. This message is formatted so that the native side of the app can understand it. In the next step of native module invocation, the native side receives the message and then invokes the appropriate native module to act. In the given example, the native side activates the camera. The last step is response back to JavaScript. Here, if the native feature needs to return something, such as a photo, it sends this back through the JavaScript bridge. The JavaScript code then processes the returned data accordingly. In this video, you learned that React Native Internals is a powerful architecture for creating mobile applications by integrating JavaScript and React on Android and iOS seamlessly. The core components of the React Native architecture are the native module and the shadow tree with the Yoga Layout Engine. A native module is code written in a language native to the platform. React Native uses the Yoga Layout Engine to decide the arrangement of components and the shadow tree to control layout calculations. The various threads in the React Native thread architecture play a key role in ensuring the application's efficient performance. The JavaScript bridge facilitates seamless communication between JavaScript and native code. The 4 steps involved in the process are JavaScript execution, bridge communication, native module invocation, and response sent back to JavaScript.